Once we go watch my I saw the test tomorrow. So this unit is rational functions. I believe after this unit comes the oh so fun conic sections where we graph and talk about, please zip it, ellipses and hyperbolas and parabolas. I think that's it. Anyways, we're going to get through this one. This one has a little overlap with Algebra 2, quite frankly. So you'll see some of that overlap here today. But the graphing part of rationals, where we start graphing like things with asymptotes, and you've seen some asymptotic behavior already. When we graphed exponentials and logarithms, we saw those asymptotes, the way a graph can approach an asymptote and head north or south or east or west. So we'll see that here in a little bit. But no graphies today or Monday or Tuesday. We're going to focus for a few days just on talking about the expressions themselves. So if you remember this from Algebra 2, nice job. If you don't, you will in a little bit. So what we're going to do is we're going to simplify expressions first of all. And then the new part that we don't talk about in Algebra 2 is stating the excluded values. So let's talk about excluded values first. And this one rule, this thing I'm about to say, if you're listening, this will get you a long ways. The bottoms of fractions cannot equal 0. Yeah, I'm gonna let you write that down. I'll let that simmer because that's going to be a carrying point for us. We cannot have the bottoms of fractions equaling 0. So when we talk about excluded values, what we mean by that is we're talking about numbers that x or n or y or p, whatever the variable is, we're talking about numbers that it's quite literally not allowed to be. So in this case, when you look at this math problem, it's a multiplication problem. So you don't actually have to perform any multiplication. We just have to look at it and answer this question. What can n not be? What can n not be? N could not be 8. If n is 8, what happens?
0.
That first fraction says 1 over 0. So we can say that n is not allowed to equal 8. So we're going to do this hundreds of times, but for now, because this is where we find vertical asymptotes, or at least removable discontinuities. But like we care a lot about where the bottoms of fractions equal 0. So the first thing we're going to say is when it says excluded values, we're going to say n is not allowed to equal 8. Okay.
What negative 1 be?
And -1 is another excluded value. Very good. So we're going to say n cannot equal 8 and n cannot equal -1. So I like to just get that out of the way first, okay? We don't talk about that in Algebra 2 at all. When I taught you how to do rational stuff like this in Algebra 2, we never even went there. We just were playing around with the factoring and crossing stuff off. And now we have to understand the excluded values because in this class, we talk a lot about the graphs of these rational expressions. And it's those bottom numbers, I say they really carry the day. Okay, so let's move past that. And now it's time to simplify. Any chance at all that you remember from the last class how to simplify one of these? I will not be even remotely offended if you don't. Right, I'd be shaking my head too, like I don't even know what you're talking about. So what we're going to do is we're going to expose factors. And the idea here is that when you simplify expressions like this, like I could show you an example on a very fifth grade level that will make perfect sense to you. If I had like 8 over 13 times 39 over 10. We're going to do the exact same thing, except at a high school level that this is. Any math teacher with any self-respect would not allow their students to actually multiply these numbers together, right? Because we like kids. We don't want you to be tortured. So what we teach you is that you look for what are called common factors, right? You would agree that those two things that I just circled have a common factor, don't they? What is it? It's 2. So we pull that common factor out and we drop the 8 to a 4 and we drop the 10 to a 5. But then we also observe that 13 and 39 have a common factor. What is it?
13.
It's 13. I can divide them both by 13, resulting in a 1 and a 3. Okay. It's not very nice to teach kids to just multiply fractions together and reduce later, because what happens usually then is you get these really big fractions and then you're stuck trying to reduce a really big fraction. We can avoid that if we're smart and we pull factors while they're out in the open. Like we assume by this point that you can spot things that things can be divided by. So, and then the teacher would tell you at this point, okay, now that everything is relatively prime, the top numbers are relatively prime to the bottom numbers, meaning they don't have anything in common. So then we would say that the answer is 12 over 5. You're good, right? Okay, so let's take that knowledge and then apply it to the high school version of reducing fractions. So we don't see any common factors yet. And the reason is because we haven't done the F word, right? Factoring. And so we assume if you've gotten through Algebra 1 and Algebra 2, which you have to be here, that you can generally factor. So we look at the four quadrants of the problem and we ask ourselves if we can factor. And the 1 is, of course, dead. N minus 8 is dead. N plus 1 is dead. But what can we do to factor this box up here? And I know this is our first foray into factoring in quite a little while. So do you see anything about the purple box? Yes, it's got some ends that are in common, right? Sometimes factoring is as easy as just pulling out a common factor. That's easy. So what else? You said n squared? I agree. So let's all agree that if we take that upper right, and I'm going to erase these excluded values just so I have a little more room. We all agree that in the upper right-hand corner, we can pull out an n squared. But I think there's something else that we can pull out too. We can pull out a 9. And so if you have forgotten this, there's zero chance that it won't come back to you sometime today. We've done all this together before. Now, when you pull out a 9 and an n squared, all you're doing effectively is just the distributive property, of course, in reverse, huh? And so if I take the first term in the purple box and pull out a 9 and I pull out n squared, what's left? Just n. Just the n, right? So again, focus just on one thing at a time so we don't lose anybody. That little term that I just circled, you see it? You agree that if we pull his 9 out, it goes away. If we pull out two of his n's, he's down to just one n. Okay, and then I'm going to copy the minus sign. Now let's consider the green egg. We attack them. Since we're just anti-distributing, we attack terms backwards one at a time. If we take 9 out of 72, what's left? Correct. 8. And we pulled out all of his n squareds, right? So that's all that's left. I need to know if you're with me so far. Good. So what we have now is we have, and I'm going to do a little bit of creative white pen work here. I might as well use it since I have it. We have an expression now that looks like this. Okay, that did not go well at all. God, I thought this is working so well. Is there an option to like bring that to the front? Yeah, or just maybe get good noob. Okay, why is it doing, stop. Stop picking on me. Oh, watch this. Undo. Oh my God. So sorry. You guys like this stuff though when this happens, don't you? Because it's like entertaining for you. I get it.
It's like watching monkeys.
I know, right? And I'm the watch the monkey. So there, I'm just gonna leave this. I'm never doing that again. So there's my new top right-hand corner, right? And so what we identify now is much like we did in the fourth grade version of the problem, we look for common factors. And now it's legal to cancel stuff out because everyone's multiplied, right? Like it's 9 times n squared times n minus 8. And so each of those in its own right is a factor that can be murdered off. So properly, when we look for things that can kill each other, we should all agree that this n minus 8 can cancel this n minus 8. You should remember that each of those is independently its own entity. It's like a factor, and it can be canceled out. So where we're at in the process right now, let me clean up. I can tell this is about to get away from me, is we're at 1 over 1 times 9n squared over n plus 1. And that's where we should be in the process, because if we killed off the n minus 8s, then that's what we're left with, right? Do you see anything else that can cancel? And choose your answer wisely. You should want to say yes, but then you should tamp that down and say no. And you'll remember at some point people getting yelled at for trying to cancel out those ends. The ends on the right-hand side are so tempting. Do you remember by chance why we cannot cancel them out? Because the cats will die. Exactly. You remember the little picture of the kitty cat? Do you remember the picture of the kitty cat? Well, let me show you the picture of the kitty cat. Yeah, it was my wallpaper for like a month. Remember, every time you do this, a kitten dies. And the purpose of this meme or GIF or whatever you people call this thing, the purpose of this is to show you that even if you, just because you see some X's upstairs and downstairs, if they're part of addition and subtraction problems, they are off limits. And you've heard that speech before. And so when we get, you like the kitty? Isn't he cute? So when we get to a point where we're tempted to look at those as cancelable ends, we're going to tamp that down and say no. The n on the bottom being part of n plus 1 makes him officially off limits. So as anticlimactic as it would be, the answer to this problem is if we get rid of these 1/1 things, the fully best simplified answer to this problem is right there. Okay. And n equals 8 is still an excluded value, as we'll learn later on in this unit. It's just not a vertical asymptote. It turns out to be what we call a hole. It's a removable discontinuity. It's a little blip in the graph that it essentially jumps over. So it's still not allowed. It's just not, we don't see it in our final answer. So you choose your excluded values before you start actually simplifying. Got it? Let's head down to problem number 3. I know that seems a little out of order, and there's no way we're getting to many of these because do you guys know what time we get out? 22? That's okay. We got a few minutes. We got 10, 12, 15 minutes. So we're good. So let's take a look at problem 3. Do you wish it were sooner than that? Yeah, sorry. So problem 3. Anything catch your eye about problem 3? Do better. That's ding, ding, ding. It's division. So you remember that we don't ever divide. Division technically doesn't even exist. Division is really just the multiplication of an inverse. So anytime someone presents you with a division problem, you really at this level should be flipping it over and turning it into times. So our first job, as annoying as it is to copy dot flop. So I'm going to take the x minus 3, leave it alone, the 7x minus 21, leave it alone, and I will switch this to times. What's going to be the top of my new right-hand side? You betcha, right? Remember, the bottom becomes the top and the top becomes the bottom. At this point in time, do you see anything that could cancel? The x minus 3s could. I agree. So if you wanted to jump the gun a little bit, you could just get those guys out right now. Like, it's fine. And again, remember, the x's independently are not cancelable, but the whole x minus 3 as a factor is cancelable. So if you wanted to, you could. But of course, we've got to do a whole bunch of factoring. So let's focus on the lower left-hand corner. I'll color code it for you, the red one. What kind of factoring could we use there? Good. So if you pull 7 out of that and you ask yourself, how would I rebuild it? It's just 7 times what? X minus 3. And then, of course, we're going way in the way back machine here. What about the upper right-hand corner? What kind of factoring is that? I don't know how to answer that question. It's a quadratic trinomial, so this is the kind of factoring, remember, where we put our 2 sets of parentheses and guess and check until it works, right? I mean, this being your third go around, this shouldn't be that hard for you. So the factors are going to look like this. If you didn't like factoring the first time or the second time, maybe the third time will be a charm, right? So tell me about my signs. 2 pluses, 2 minuses, or 1 of each. Needs to be 2 minuses because they multiply to make plus 27. but they add to make -12. The only way to accomplish that is with two minuses. So I'm going to put a minus and I'm going to put a minus. And the math is not hard. What numbers are we looking for? 9 and 3, right? Is this coming back to you yet? Good. Because we really can't graph rationals if we can't dismantle them to some extent. Like more complex rational functions, we have to be able to tinker and toy and factor to see the things that enable us to put down the characteristics. The asymptotes are the primary, the most important thing. So we're going to take our factored down version of the upper right-hand side. We're going to pull it back in. And this is where the current state of affairs is. And I believe there's a lot of murdering to happen here. So I'm going to go through and just start offing things. And I'm going to point out, hey, earlier, remember the x minus 3s? Just take them out. What else do you see? There's another pair of x minus 3s, right? Take those guys out. And then I believe that's going to be it, huh? So what's our final answer? That's it. So a fully simplified is x minus 9/7. So we need to go back and look for excluded values. And that's my fault for not doing that earlier. I should have done it like I said I would. So if we go back before I drew all the red X's, but after I switched it to times, that's important, okay? Don't base any excluded value stuff on a division problem. You want to base it on what it actually is. And so inside this purple box is the math problem. And it's fully out there exposed for the world to see. I believe there's only one excluded value. What is it?
3.
It's 3. X is not allowed to equal 3 in this problem because if it does, then we get at least one denominator that goes to 0. And if you're wondering about the 9, because it started on the bottom, I want to say again, I don't care. It's not really on the bottom because it's a copy.flop scenario. So it really never is on the bottom. It looks like it, but it's just because it was division. Okay. I want to make sure we get to problem number 4. And then we'll probably, I doubt we'll finish them all. But if we could get 4 done, then we can reintroduce the idea of negative factors, opposite factors. So for 4, sorry about the B's. We could just do it with X's if you want. You want to just change them. B's look like 6s, especially if huh? You don't want to switch it? Oh, okay. I don't want to make anybody mad. B's it is. We're sticking with the B's. The first thing we're going to do is copy dot flop it. So I'm going to write it as 3 over, and I'll try to make my B's look good. Oh boy. B squared plus 3B minus 4. And then I'm going to switch it to times, and then I'm going to move the 4 minus 3B minus B squared upstairs and put the 1 downstairs. Not yet. The entire purpose of this problem, the entire reason why when I was picking examples for this notes page, the entire reason I allowed number 4 to survive was because of what we're about to talk about. And I want to rearrange them just like Brady does. I hate that. Like, you're a good mathematician if you hate that, because you should. I mean, having things all out of whack like that is funky, but you're not allowed to just switch them because there's minuses involved. And with minuses, we have to be really careful. So what we want to do is, first off, we want to pull out a -1. So if you take that entire thing and you divide it by -1, and by the way, do you notice this? I don't know if I have to say this out loud, but do you notice how the terms kind of match?
Yeah.
Right? There's like a B squared and a 3B and a 4, and then the other one has, look, a B squared and a 3B and a 4. But the signs don't match. And that's where the power of what we're about to learn for the second time, by the way, you again also learned this last time, but that's okay. If you pull a negative out of something, which is perfectly fine, it's like GCFing by a negative, but all it really does is change all the signs. So if I pull -1 out of that thing that's in the red parentheses, what does it become? Well, don't go too fast, okay? Let's just one thing at a time. What does the 4 become?
-4.
It becomes a -4. What does the -3B become? A +3B. Okay, and I don't mind if you skip this and go a little faster next time, but I'm sure not going to this first time. And then what does the minus b squared become? Plus b squared. It's at this point now that I'm going to rearrange the terms like you asked. And the reason I'm free to do it now is because the signs of the first terms are going to match. So really, if you think about it, if you take this, I'm going to color code this for you. If you take this positive b squared and move it to the front, you get this. And if you take the plus 3b, keep it in the center, you get this. And then if you take the minus 4, move it to the back, you get this. I would venture to say that probably the most common error that I would see in a case like this would be, I'm going to do this on purpose, so you guys please call me on my blunder. I would appreciate it. Is if I just put this. You sure do, right? Like you can't just willy-nilly pull a negative out of something and act like you didn't do it. Like we're not solving an equation here. With equations, you can divide by stuff and no one even has to know. But with an expression, things don't go away. They stay. So I need to parenthesize this and then stick the negative or the -1 out front. And that negative could go quite literally anywhere. If you were feeling crazy, you could slap the negative over on the 3, stick it down on the 1, right? But it's fine right there. Good so far? Okay. So that's a power move. You'll use that anytime you see things that your spidey sense tells you are backwards. Do you see? Could you look through your worksheet real quick, your note sheet. When's the next problem you see where we better know that trick? 7, 100%. There's some x minus 10s, but then you got that weird guy, the 10 minus x, and you're like, I'm going to pull a negative and flip you, right? You could flip things when you pull a negative. Do you see any more? 8 has another one. It's got that funky 10 minus 10x that we know we want as 10x minus 10, so we can pull out the 10 and make it look like the x minus 1. So that's a good trick for your toolbox. And now that we've gotten here, let's just factor this. And the only factoring to happen here is those big, long expressions need to be factored down. What does the red egg really equal? Yeah. So we have 3 over b plus 4 times b minus 1 times the negative of, again, b plus 4 times b minus 1. Good. And honestly, if you didn't even want to factor those, looking back at this now, could you have just murdered them off? Yes. You could have just said, hey, all you b squared plus 3b minus 4, go kill that other b squared plus 3b minus 4. Right. So factoring was pretty silly in that case. Anyhow, everything is done to the point where now we can just start offing things. So b plus 4s, take a dirt nap, b minus 1s, take a dirt nap, and now we're just left to clean house. Really, at the end of the day, what's left? What is what is the answer? The answer is -3. That is the best we can do. That's the best way to say that. You got it? So that is the goal. I don't want to do any more problems because I think we're all kind of done. But here's the deal: we're gonna resume this on what is it, Monday, and then we'll have an actual assignment. So this is not an assignment. This is just notes. How many we do? Do we do 3 or 4?
3.
We did 3. That's not very good, but that's okay. We'll do more next week. Sound good? So finding excluding values, finding, oh, by the way, we didn't find any excluded values. What is wrong with me? God, you think I could, thank you. What are our excluded values in problem 4? What is B not allowed to equal? B can equal 0 all at once. Say it again. B cannot equal -4. And I will draw your attention to it with a large purple circle. Do you see it down there at the bottom of the TV? If B is -4, that's bad. So B is not allowed to equal -4. What else can B not be? B also cannot be 1. So remember, once you have the factors out and exposed and it's in a multiplicative state, when you see the bottoms in a multiplicative state, make the bottoms not equal 0. That's the goal.
And that's why we needed the fact.
Good call, man. Yeah, so it turns out the factoring was useful after all. It helped us to see the excluded values. I feel so much better about that. All right, cool. So we're done for today.